G'day. In this series of videos, we're using Psychopy and Python to create the line bisection task. And remember, that task is useful in probing visual-spatial attention, particularly in patients or people who have possible visual neglect or some sort of problems with their attentive process whilst processing visual information. Now, in the last couple of videos, we have started from nothing. We started with an idea of mimicking the Kim et al. Paper from 2005. And then what we did is we created a very general workflow in our Python and our Atom and our command prompt. And then we basically pulled apart the Kim paper. We got all the information that we needed, and then we slowly built up our program. If you haven't seen those previous videos, then stop this one, go back to those previous videos, and work your way back up. If you have seen those previous videos, then you remember where we left off was we had some ability of keeping track of the trial count that we were currently on, and also keeping track of the stimulus or the subject's responses for that particular trial. What we're going to do in this video is we're going to actually start to implement some of the randomization of stimuli. Remember, if we go back up to the top of our program here, you remember that during the task, the subject was told, hey, which side is longer, which side is shorter. They had to choose between one of those two choices, two alternate force choice tasks. But then what they did is they gave them 40 trials per block. So we're reading this experimental session. They had 40 trials per block, 4 trials per session. And then within that 40 trials, only 10 of them were actually bisected. 15 actually had a left elongation, and 15 of those had a right elongation. So, and that these bisected left longer, right longer trials were actually randomized within that block. Okay. And so this is what we're going to do now, is we're going to essentially create a Python. We're going to implement this randomization in Python using NumPy and just some general array manipulation. So the documentation that we're going to use for this is NumPy. Okay, it should come along for the ride when you download your Python. Your Psychopy. So make sure that you can import NumPy, because we will need to get NumPy on board. And so in our import from other libraries, we will import NumPy as NP. This is a standard way of getting NumPy into your environment here. So import NumPy as NP. Anytime we need to get access to the functions of NumPy, we just have to type np dot give us something. And you can see a bit of a heads up here. We're going to use the NumPy random.shuffle, and this modifies a sequence in place. Because what we're going to do is we're going to create a sequence of 40 trials, and then we're going to shuffle them up. And then we're going to look through each one of those trials and say, hey, was this a left longer or was this a right longer? But first we have to create our array with the 40 trials in it. So let's take a look. We have 10 trials. So in that 40 trials, we have 10 that are bisected. We have 15 that are left elongated and 15 that are right elongated. So here we have the ability to come up with our own way of encoding that bisected left or right longer. So what I'm going to do is I'm going to say, if it is bisected, it's going to equal the number, say, let's say it's going to equal the number 0. Okay, this is just for our own encoding. And if it's left elongated, we're going to give that a number 1. And if it's right elongated, it's going to be given the number 2. Okay, let's go over to our sandbox. And what we can see here is I've already created one way of doing this. Okay. What we're doing is we essentially want to create an array, okay? And in that array, we want 40 items. We want 15 of those items to refer to left elongated. We want another 15 of those items in that array to refer to right elongated, left elongated, and right elongated, 15 of each. Sorry, I forgot which one I was. And then we want 10 of those items, to refer to a bisected line. And so there's a couple of ways that we can do this. This is one of the ways, and it's not going to be the quickest or cheapest way of doing it. But if you're not confident with control statements, so things like if and else statements and Boolean and logic, then this is a good little example that we can go through to get a little bit more confident over for loops and Booleans and control logic. So let's just run with this. We don't need the SciPy anymore. NumPy. We'll clear that, but let's just see what we've got. So this is the sandbox that we were running on before, okay? And what I'm doing here is I'm creating an empty array. So in Python, to create an empty array, we just create the variable and then we give it open and close square brackets. So this is basically saying, hey, think of this as a container. And into that container, we can append or add into it anything we want, okay? In our case, we're going to give it the number 0, the number 1, or the number 2. Why is that? Well, if you remember, we said a bisected line is equal to 0, a left elongated line is equal to 1, and a right elongated line is equal to 2. And so what we're going to do, create an empty array, is we're basically going to say, okay, well, we want to have 40 elements in this array. So we'll create a for loop and we'll say for I in range 40, so remember, I will start at 0. 0 is inside this range of 40, okay? So range of 0 to 40. So if I put something like I in range 0 to 40, it's still going to work. But we can just leave 40 there. And then what it's going to do is it's going to say, okay, if I, so remember, this starts out at 0. So the iterator, I starts at 0. Now, there's nothing special about the letter I. It's typically used as the first instance when we need an iterator or a for loop. We could have anything in Python. We could have this as the letter N. Okay, so the iterator could be N. Where are we? Okay, but if we do have N, then we need to change all of these to N. And so we could think about this as the number or the position in the array. Okay, it doesn't really matter. If we have up here the iterator, we declare the iterator and we refer to it as something. Whenever we need to later on make a decision based on the position or the value of that iterator, we have to use the name that we gave it before, okay? So let's leave it at N for now, okay? There is a little, I need to caution you in that if you put a for loop inside another for loop, so if we said for N in range 40 and then we said for N in range 100 or something like that, so here we've got a loop inside a loop, okay? That's not going to give us any, that's going to give us a lot of hassles because we've tried to declare this an iterator twice. And so you would have to then say, okay, we actually have to change the name of the second iterator and then we'll do stuff inside that nested loop. We will actually get to a nested loop in our main program loop later, but for now, we'll just leave it at N. Okay, so N starts at 0. 0 is in the range 40. Great. So now we say, right, if N is less than 15, well, yeah, it is, we want to get this array and we want to append, okay? Append means add on into the end, at the end position. We want to append the number 2. And once we've done that, this loop then goes all the way down to the bottom. It will come back up again. It will increment the iterator. So N is now equal to 1. Is 1 in range 40? Yes, it is. And then we say, okay, so if N is now less than 15, it still is because now it's 1, we will then append to the end of that array, okay, the number 2. And then it will come down to the bottom. And then it increments it up to 3. So what you can see here is that For the first 15 numbers, when n is less than 15, we're going to include or append at the end of this growing array. The array starts out with nothing in it, and then it will start to grow. We will append into it the number 2. And then suddenly, n is now equal to 15. And so if n is less than 15, well, no, it's no longer less than 15, so it skips over this. This is no longer true. And then it says, okay, now, if n is greater than or equal to 15, yes, now we are equal to 15, so this is true. And our number is less than 30. So we're basically saying if n sits between 15 and 30, or 15 and just less than 30, this is what we want to do. We then want to append the number 1 into our array. And so every time we append something, it just takes the array as it currently stands and basically adds on to the end of it the value or whatever it is that you want to add to it. And then it will go to the loop again, take that array, add the stuff onto the end, and then, it'll take that array. So that array over time will get longer and longer and longer, more elements in that array. And what we see at the end is the latest bit of data or the latest thing that we've tacked on to the end. And then once n increments up to now, let's say n is equal to 30. So n is greater than or equal to 15. Yes, that's true. But n is now no longer just less than 30. N is 30. So this is now no longer satisfied. We then say, okay, n is greater than or equal to 30. Brilliant. And then we'll just append the number 0. So you can see what we're doing here. We're appending the number 2. And remember what the number 2 was? 2 means right elongated. So that means we're appending our right elongated trials. Okay. We're going to use this, trust me, we're going to use this in a little bit. It may not make sense now, but it will. And now we're going to append our left elongated trials. Okay, and then the last thing we're going to do is we're going to append our bisected trials. Now, we're not actually appending the trials themselves, but we're just appending the key, all right, to our program to say, hey, for this trial, we want to present a left elongated. And then we'll change the stimulus so that the left side is elongated. And then the next time we go through our main program loop, we increment that iterator by 1. And suddenly, when we look at our final array, our randomized stimulus presentation array, it says, for this trial, please present a bisected line. And so therefore, we will then tell that bisected function, that stimulus function, hey, this one has to be bisected. What we're doing at the moment is we're just creating the stimulus presentation order array using the keys that we defined in our main program, 0, 1, 2. Okay. So if we print out here, okay, if we print out stim side, after we've completed all of our appending, okay, so this loop here is this for loop is going to stop when it gets into the 40, when it gets its 40 trials. But what you should see is we should see 15 lots of 2, followed by 15 lots of 1, followed by 10 lots of 0. Let's see what we get. So again, we're running this off our sandbox. So Python 3 sandbox. Okay. If we've done it correctly, hopefully. Thinking. World's oldest computer. Okay, here we go. It's given us back an array with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 number 2s. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 number 1s. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 number 0s. And so if we were to now feed this array, okay, into our main program loop, Okay, so now if we look at our main program, for I in range 0 to number of trials, we would then say, okay, we would then present basically 15 right elongated trials, followed by 15 left elongated trials, followed by 10 bisected line trials, okay? Because we could now use this iterator here, okay, to look at the position of our stimulus presentation order array. And it says, okay, for the first trial, we'll use this one, and then we need to put that into our fixation, our bisected line stimulus, okay? What I'm trying to get at is we need to shuffle the order of this array now because it's randomized. We don't want to just do 15 left elongated back to back to back to back because your subject is going to be wise to that, where we are basically biological pattern detectors. We are here trying to look for patterns in the world. And if they get any sniff, right, of remember, your subjects are stupid and they're going to destroy your experiments, right? And so if they get any sniff of a pattern, that's going to bias their responses. And that's not what we want to check. We want to check their visual attention, visual-spatial attention. So we have to take this array and we have to jumble it up and then use that jumbled array to generate the order of presentation for our stimuli. So this here is just generating an array with the correct number and the correct keys of the responses or the trials that we want to do. We need to now shuffle that array. And that's where NumPy comes in. So here we go. This is the documentation from NumPy. I literally just in Google typed in NumPy shuffle, and this was one of the first responses that came up. And it says here, numpy.random.shuffle, parentheses x. So x is the array of values that you want to shuffle. It's not going to add any more values in. It's not going to take any values out. It's just going to take those numbers and then shuffle them around, and then basically that's your new random array. It doesn't return anything. It just takes them, messes them up, and that's it, okay? So it modifies the sequence in place by shuffling its contents. It does what it says on the box. So here, we're printing out stim side, which is our array. And then what I'm going to do is I'm going to say MP, remember, that's how we import NumPy. So this is what we refer to the functions of NumPy as, MP.random.shuffle. And that's what we've got here. So .random.shuffle. We don't need NumPy there because we're calling it MP. I'm repeating myself a little bit. And then we want to shuffle, please NumPy, can you please shuffle our stim side array? It will only work on arrays or a sequence of numbers. So what we'll do is we'll then print out those values, that stim side, after we've shuffled it. And we'll see just what happens. I think you will know what happens. So the first time we print out that stim side, it should be in order. And then the second time we print that out, it should now be jumbled. And let's have a look here. So there is our array in order, okay? And then here, have a look. Here is our jumbled array. So 2, 1, 1, 1, 0, 0, 2, 1, 2, 0, 0, 2, 2, 0, 1, 1, 2, 1. So if we ran this again, it will again be shuffled. It's randomized. And so our subjects have not a chance, not a chance, what bad England, they will not be able to pick out any patterns in the stimulus presentations, okay? So if we have a look here, this is the array that's been shuffled. I'm now just comparing this value to the previous time we shuffled that array, and look, they're different, okay? So this is what we're going to do now. We're going to basically bring this into our main program, Command C, and we're going to put that up in our variables, because this is the sort of area where we can do that sort of stuff. And then what we're going to do is, we don't need to print it out anymore. Oh, we do need to shuffle it, sorry. Okay, so we'll shuffle our stimulus presentation, okay, order, spoken like a good Australian, order. Now, what we are going to do is we're going to use this stimulus presentation order array to tell our bisected stim line length, right. We need it to be left longer, right longer, or bisected. So we will need to now put in, what should we call it? We should call it something like length, line. No, line length is the length of the line, and then we'll say side. Yeah, we'll just call it side. Let's just say long side. Long side. And so therefore, now that we've got the long side here, we will now basically have to say, right, in our bisected horizontal line, we have to change its position, don't we? Because remember, in this trial, the vertical line always stays in the middle of the screen, but it's going to be the horizontal line that shifts to the left or to the right. By how much does it shift to the left or to the right? Well, we've got that information when we pulled apart the Kim paper, right? They said that the vertical offset, so this is by how far left or right that vertical line is always 1 degree visual angle, and we know that that's going to be 29.91 pixels, and we're going to call that 30 pixels. We'll round up. And so therefore, we now know we are no longer just creating a bisected line, we are creating our stimulus. Okay, and we know that the bisected, okay, left equals right. Okay, so the length of the left equals the length of the right. If it's left longer, okay, that means that the left is greater than right, which means we have to shift the position of the line to the left a little bit. Have a think about it. We want the left side to be longer, and so therefore we have to start the left side of that line to the left of where it would normally be, if that makes sense. And so we have to actually shift the position of that line negative 30 pixels to the left. Right longer. Now, left is less than right, and so that means the left is now shorter, and so therefore we have to shift that line to the right a little bit, and that means that we're going to shift it in a positive direction, so plus 30 pixels, if that makes sense. The vertical line stays as it is forever and ever and ever. It's the horizontal line that changes its position. Right, so this is the rule that we're going to need. So if long side now, so if the trial that we are putting in, if the current trial says we need the left side to be longer because it's a number 2 or it's a number 1 based on what we did before. In fact, we need to know that. I can't get out of that. So left elongated equals 1. So left elongated equals 1. So if long side equals 1, that means the left is longer. That means we have to shift the position to the left. If it's bisected, that means that it's the number 2, I believe. 0. Okay, so if it's 0. So if long side equals 0, we do nothing. It's basically position is as per normal. Excuse me. And if long side equals 2, that means that current trial, we need the pixels, we need the left line, we need the horizontal line to be shifted to the right by 30 pixels. So that's a positive displacement. Okay, if that doesn't make sense, give it a shot. Go into the sandbox and push forward, create your stimulus, and push it to the left and push it to the right, and just make sure that the left side will be longer or the left side will be shorter, depending on whether or not you've made it negative or positive, the X position. So now what we've got here is This is for a bisected line, okay? So what we've written here is correct for 10 out of those 40 trials. And so what we could say is if long side equals 0, okay, that means we've a bisect where we need a bisected line, okay, then all of this works. Great. However, if long side equals 1, okay, this is no longer correct. Okay. Well, in fact, we don't need to put all that in there, do we? We just need the horizontal bit to be different. So we can Command X that, bring that out into here, because the vertical lines are the same, right? We just have to change the horizontal position. Okay, so this now means we'll Control C that. And so now the position is going to be, it's 1, so that means we have to go minus 30 pixels to the left. There we go, that's it. The vertical line stays the same. Okay, and we'll go Control C. We'll copy this again. So here's the beauty of having a function, because now we just have to change the function, and all the rest of our program we don't have to modify. We don't have to write 6 or 10 or 12 different versions of the same stimulus and then play them separately. We're just calling the function, changing the positions, and then that function is drawing all that stimuli into the window in memory. And then next time we call win0.flip, it's just going to squirt it onto the screen. No problems at all. And so now we need that to be positive 30. Okay, let's just run through this. If the current stimulus side, okay, says returns a 0, okay, so if this array here that we create here returns a 0, the position of the line is going to be 0, 0, so that means it's going to be bang straight in the middle. If, however, for that trial it returns a 1, we put a 1 into it, it's going to shift it to the left, and that means that the left side was longer, and that means, yep, that it's a negative displacement, the left side will be longer. If it returns a number 2, or if we pass it a number 2, sorry, not returns, that's different. If we give it a number 2, then that means we have to shift it across to the right, a right displacement, which means that that right side of the line is going to be longer relative to the left side. Okay, and then the vertical is exactly the same. We then draw the horizontal, and then we draw the vertical. Not a problem. Brilliant. Lovely. I think this is going to work, but we have to do something first. Remember, whenever we draw that bisected stimulus, we have to pass the arguments now. And in the first case, that argument, the first argument is, well, how long of the line? How long a line do we want to present? We haven't touched that yet. We will need to randomize those orders as well, but we'll get into that. But then we've got this second positional argument where we're saying, hey, long side. And that long side is going to be based off what the current position in the stim side array is. Right, so this is the randomized array containing 40 elements. Okay, and so here we've got an iterator that will go through 40 elements, 40 trials, because remember, we've got 40 trials. We've hard-coded this to make sure that they marry up. And so what we do now is we say, okay, whenever we want to present our stimulus, we'll give it the same length. It'll be 112 pixels. That's not, 1112 pixels. That's not a problem. But now we want to tell it what position in the stim side we are. What have I done here? Have I done some nastiness? Okay. Because this is an array, we should have some way of being able to access the different elements inside that array. That's called indexing the array. We want to get the index or the value at a certain position in the array. For instance, we have a look at these arrays that we've created earlier. So here, we're just going to look at this array here. We've got 40 items or elements in that array. The first position is called index 0. Remember, 0th counting for Python. So if we go and say, hey, dear Python, can you please give me the value at the 0 index, the first position, it will then say, yeah, okay, it's a number 1. And then we're going to use that number 1. So when this is 0, because remember, this is 0. So now we're saying, okay, in this array here, can you please give me the value at the 0th position? Okay, which in this case, it would give us a number 1. And then since we're passing this as a positional argument, as an argument to our stimulus, so now this long side is 1. And then we said, okay, if long side equals 0, we need to do this. No, that's not correct. If long side is 1, yes, that's correct for this trial. It's then going to give us this. And that means that we're going to shift the position of the line by 30 pixels to the left and give us a left longer stimulus. Does that make sense? I hope it does. Once we've done this first trial, remember, this iterator comes up to number 1. Okay, and so therefore, stim side, now we're at the position 1, and so we've gone from the 0th position into the first position now, or the second place, okay, if that makes you think of it any easier. And so it's going to then pass into our function, the number 1. It just randomly happened to give us a number 1 again, okay? It could have been a 0, could have been a 2, okay? And then it's going to give us and draw us this line again, all right? And so now what we can do is we're randomizing the presentation of the order. 10 out of the 40 trials will be bisected. 15 out of the trials will be left longer. 15 out of 40 will be right longer. Okay, but they're going to be randomized now. So what we need to do is just to make sure that the number of trials that we give it is 40. So then we're all running off the same number of trials and the same stimuli and the same stimuli order and everything. Okay, but now what we can do is we now have access to print. Okay, current line length is, okay, stim side, oops, oh, did it again, stim side is, and so now we know, because we've got the key to what we created, we now know that the line length, or the current trial line length, is left longer, right longer, or the same. And so now we've got the current trial, we've got whether or not that trial would be left longer or right longer, all bisected, and then we're also able to pass into that, well, what stimulus do we need to present? Okay. I hope that makes sense. Let's give this a shot. Let's see if we've angered any pixies inside the computer. So Python 3. It is a little bit complicated and a little bit complex to get your head around. But essentially what we're doing is we're just trying to create the random order of stimulus presentations. We've got an error here. Stimside.append. Stimside is not defined. Let's see what we've got. What have I done here? This is an error on line 88. 88. 86, 87, 88. Okay. I haven't given it the empty array. Stim side equals an empty array. So hopefully this will work. So what it does at the start is it creates the array and then fixation cross. Oh, I reckon that was left longer. Oh, not sure. Left longer, this is really hard. That looked like a bisected, I don't know. Left longer. It's really difficult. What we might do is I'll quit out of this, okay? And so here we've got the trials that we've just done. And so the line length is number 2. And so what did number 2 mean again? Let me just close this down. so we don't have to look at it. So number 2 means that the right side was longer. Okay. So we had a right side was longer, left side was longer, bisected, right side was longer, left side was longer. Okay, so it looks to have worked, and we did about 10 trials. Okay. Oh, we did, 12 trials, 13 trials, 14 trials. Okay. What we'll do is we'll just set this for 2 seconds. So it will present the stimulus for 2 seconds. That should give us a pretty good chance of measuring the distances. I'm just going to use my fingers. Just spread them and go, all right, it's about this or it's about that. Okay. I don't know what it's going to be. So that one. Oh, that's still really quick. All right, let's have a look. That looks bisected. Right side was longer for number 3. So let's have a look here. Right side was longer for number 3. Okay, so right side was longer, number 3. Line length is 2, so 2 is bisected. What we'll do actually is we'll make this a lot bigger. So we'll put this at say 300, okay, and minus 300. We'll just accentuate the differences there, just to really, make it clear that we are pushing the line length around. It should be quite clear now. Yeah, you can see that there. That's right longer. Bisected. Right longer. Right longer. Right longer. Why aren't we seeing any left longers? What have I done? There's a left longer. So I just happened to randomize that. So you can see there, right longer and left longer are working. Okay, there just happened to be a lot of 2s there. Yeah, you can see that trial number 2, trial number 3 to trial number 4. You got a whole lot of 2s there. Okay, great. And then that last one, the left side was longer. So look, it's working, and we are able to push it around by the correct, in the correct direction, the correct side. Okay. So now let me just double check how long we need to push this around. Vertical line. So it's 30 pixels. Okay, so make sure that it's 30 pixels again. Great. 30 pixels. Bisected is fine. So if it's 0 is bisected. 1, I'm just double checking this. 1, it is long-sided. 2, it is going to be right-sided. Great. Excuse me. So now let's have a look. So that's working. What we will need to do at some point is randomize the order of the line lengths. Now, how are we going to do that? Well, we can probably do it in the same fashion again. We can create this, excuse me, for n in range 40. So we can do this again. And then what we can do is, we don't have to worry too much about doing a lot of for loops and looping and stuff. They are quite slow computationally. But because we only do this once at the start of our experiment, it doesn't really bother us too much that we're going to have to do all these loops. So we can do this again, but we will change this now and encode our line lengths. So if it is a 0, it's going to be 36 degrees. If it is 37, we're going to call this, so now we have to say 1148 pixels, and we'll give this, we will give this a 1. If it is 1178 pixels, we'll give this a number 2. We'll say 1212 pixels, we'll give this a number 3. And if this is this, it's 1248 pixels, we'll give this a number 4, okay? So here we're now just encoding the line lengths between 0, 1, 2, 3, and 4, okay? And so now what we can do is exactly the same thing, create another for n in range something, or for p in range something, it'll be range 40, we'll then create the shuffled array to give the different line lengths. You don't need to see me do that. I'll pause the video now and we'll get back to that in a little bit. 2 seconds. Okay, just finished that, and I've realized that we don't actually need to encode these line lengths between 0 and 4. We'll leave it there, but you'll see why we don't need to do that in a little bit. Because what we're going to do is we've created another for loop here for p in range 0 to 40, and then what we do here is we create the line length array, and we just append into that the actual pixels, the pixel length for the 36, the 37, the 38, the 39, and the 40-degree visual angle stimulus. Now, you'll ask yourself, well, why have you gone between 8 and 16? Or why is it every 8? Well, remember, we've got 40 trials, and we've got 5 line lengths. And so each of those 5 line lengths will need to appear in the stimulus array if we're going to be equally spaced or equally presented an equal number of times. 8 times in total, so 8 times 5 is 40. That's why we've got 8. And so we're doing it exactly the same way again. We're creating just an ordered array. The first 8 are going to have a 1112. The next 8 will have 1148, then 1178, blah, blah, blah. And then what we can see here is that we then random.shuffle the line length array here. Okay. Now, you'll notice, for instance, I've just had a look here, you'll notice that these values here differ by 1 degree. And so therefore they should technically differ by about 30 pixels. And they do differ by about 30 pixels or so, but it's a non-linear difference. And so therefore don't get hung up if they don't exactly differ by 30 pixels there. The calculation of the linear distance based on the angle subtended. Anyway, the point is, now we have access to this line length array that's going to tell us, hey, for this trial, we need to present this length of a line. It's now randomized. I've checked it. Each of the line lengths do appear 8 times, and they do appear in random order. And so now what we can do is, for the line length positional argument, we're already passing it the line length here, so that's great. We don't have to do anything there. But what we do need to do is get rid of this hard-coded variable, and we say, okay, line length array, we need to pass it the current position of our trials. And then what we can do is line length is, okay, so that's not line length, so we'll say longer side is, and now we can say print, okay, line length is in pixels line length array, the ith position of that. And so if we run this program now, we should hopefully see different line lengths. Again, it may not be so clear that they are different line lengths, but we've tried it before and it should work. And so therefore, what have we got here? Line length is not defined. Line length I. Okay, line length, maybe it's line length array, is it? Yeah, okay, line length array. So we should hopefully see some long ones and some short ones. Line lengths, that is. So I was thinking. Okay, that looks a bit longer to me. It's fairly long. Okay, we'll just quit out of that. And so it looks like we had a fair number of different trials. They had an 1178. Let's have a look here. The first trial was, yes, 1178 and then 1248. Okay, so this is all looking quite good. Okay, so 1248. So there was two 1248s in a row. And that's perfectly reasonable if on a truly random sample. Okay, so now we have, let me just set this back to 0.18 seconds, so it'll be nice and quick. So here we have our very basic task. We've got random bisected left side, right side line lengths. We've got left side, right side longer. We've got random line lengths. All of the stimuli should be at the same, or at the correct distances and sizes and colors and all that sort of stuff. And what we've also got here is an ability to iterate and to control the input coming in from the subject, but also to control the stimulus presentation. How long have I gone? 46 minutes. I think I'll stop this video here. It took us a fairly long time to get our way through this. But that being said, hopefully you should have some idea now of one way. It's a pretty dunder-clunker way of going through it, so it's a pretty crude way of doing it. But it's one way where we can randomize our stimulus presentation and also get access to each parameter for each trial. And that will be important in the next video when we save and we record what the subject is doing, because we will be saving our data as a CSV file using pandas as a data frame. Okay, we'll leave this video here. Hope to see you in the next video. If anything is troubling you or having any concerns on this, write a comment down below. We'll see what we can get through. Or watch the video again, or hopefully I've used the correct terminology that other people use on YouTube. You'll be able to sort yourself out and, figure out just what the heck we're talking about here. Okay, a lot of complicated stuff here. See you in the next video.